Hi, and welcome to the second part on Numpy array operations. Hi, I'm Raghavendra, an expert in AI, ML, and data engineering. By the end of this video, you will be able to apply different operations on Numpy array. First, let's import the Numpy module. Let's create a Numpy array over here, and let's check the shape. It's a 4 by 4 matrix. It's a two-dimensional array of 4 rows and 4 columns. First, we are going to learn what is the split method is going to do. Split is going to split the array into equal parts. So, np.split, I'm going to pass the array. I'm going to ask for the number of splits. I'm going to ask for 2 splits on axis 0. Right? And on axis 0, I'm going to ask for 2 splits, and let's see what's going to be the output. On the horizontal axis, the array is going to be split into 2 equal parts. I want 2 exact 2 equal splits. Right? So 1, 2, 3, 4 and 4, 5, 6, 8 is going to be one Numpy array, and 7, 8, 10, 11 and 12, 13, 15, 19 is going to be another Numpy array. So this is what you get when you ask for 2 equal splits on axis 0. Note, split is always going to give you equal splits. Unequal splits are not possible using split function. So np.split, if you want to ask for 2 equal splits on axis 1, let's see what happens. Right? So you're going to have this array 1, 2, 4, 5, 7, 8 and 12, 13 part of one split, and 3, 4, 6, 8, 10, 11 and 15, 19 part of the second array. So you have seen how to split on the horizontal axis as well as how to split on the vertical axis, that is axis 1. Now I ask for 4 splits on axis 0. This is the output you get. The first row will be one split, second row will be another split, third row will be another split, and fourth row will be the last split. Likewise, you can as well ask for 4 splits on axis 1. You're going to get each column as separate splits of the array. Suppose I ask for 3 splits. I have a 4 by 4 matrix and I ask for 3 splits. Let's see what happens on, I ask for 3 splits on axis 0 and let's see what happens. You're going to get an error. So it's impossible to get 3 equal splits when you have a 4 by 4 matrix. Likewise, it's impossible to get 3 equal splits on axis 1 when you have a 4 by 4 matrix. In either of the cases, you're going to get an error. Moving on, we have seen about split, how I'm going to split a Numpy array into equal parts. Let's look at what concatenate does. So let's take 2 Numpy arrays. So here are the 2 Numpy arrays. Both are a matrix of 2 rows and 3 columns. And let's concatenate them on axis 0. Let's see what happens. So both the Numpy arrays are going to be concatenated on the horizontal axis, one beneath the other. The first Numpy array 1, 2, 3, 4, 5, 6 and the second Numpy array below that, that is 11, 12, 13, 14, 15 and 16 beneath that. So they get concatenated on axis 0 or the horizontal axis. Likewise, to concatenate 2 Numpy arrays on axis 0, the number of columns in both the arrays have to be the same. Otherwise, you will be unable to concatenate on axis 0 or the horizontal axis. Let's now concatenate these 2 Numpy arrays on axis 1. Yep. So the Numpy arrays are being concatenated on the vertical axis or on axis 1. To concatenate 2 Numpy arrays on axis 1, please note the number of rows, right? Number of rows in both the Numpy arrays should be exactly the same. If it is non-uniform, you will be unable to concatenate. Let's take another example of 2 Numpy arrays. The first Numpy array is of shape 2 by 2 and the second Numpy array is as well of shape 2 by 3. And I try to concatenate these 2 Numpy arrays on axis 0. Let's see what happens. You get an error. right? So the reason for this error is the number of columns. There is a mismatch in the number of columns between the two arrays, and you will be unable to concatenate them on axis 0. Let's take another example. Here are two Numpy arrays. The first Numpy array is 1 by 3, 1 row, 3 columns, and the second Numpy array is 2 rows, 3 columns. And let's see what happens if I try to concatenate on axis 1. You're going to get an error. The number of rows has to be uniform when you will have to concatenate on axis 1, but unfortunately here both the Numpy arrays have non-uniform rows. The first has just 1 row and the second has 2 rows. You try to concatenate on axis 1, you are unable to do that, you get an error. You'll have to be a little careful while you're performing these operations to make the Numpy arrays compatible before concatenation. Moving on further, head stack and V stack are very similar to concatenate. Head stack is similar to concatenate on axis 1, and V stack is same as concatenate on axis 0. So either you are horizontally concatenating or you are vertically concatenating, right? So here are the two Numpy arrays. And I say np.vstack is same as concatenate on axis 0. You are vertically stacking them along axis 0. Horizontal stacking is you are stacking them horizontally side by side along the axis 1. So here is the resultant Numpy array after performing the head stack and the V stack operations. Here are the key takeaways from this video. Split function is used to split the array into equal parts. Two Numpy arrays can be concatenated either on axis 0 or on axis 1. Head stack is same as concatenate on axis 1, and V stack operation is same as concat on axis equal to 0. Two arrays should have the same number of rows to concat on axis 0. Two arrays should have the same number of columns to concat on axis 1. Thank you for watching this video.